So finally now we are looking at solving a system of 3 equations and 3 unknowns using an augmented matrix. Please note that if you look at the process as it's shown in your lesson for a 3x4 matrix, the 6 steps that they list, that's all that matters. For instance, there are certain ways that you can get there in less steps, like with this matrix that we're given here, or with this system of equations, the 2x minus 5y plus 3z equals 8, 3x minus y plus 4z equals 7, and x plus 3y plus 2z equals negative 3. I'm going to choose as the first step to switch to interchange rows 1 and 3. The reason being is because the first step is we want 1 in row 1, column 1. Now you could get there by multiplying row 3 by negative 1 and then adding it to row 1, because 1 times negative 1 is going to be negative 1, and then add that to 2 and you end up with a 1. But that's going to involve more work, obviously, than just simply switching rows 3 and rows 1. So I'm going to make, to start off, row 3 becomes row 1, and then row 1 becomes row 3. And that's going to give us 1, 3, 2, negative 3. Row 2 stays the same, 3, negative 1, 4, 7. And then row 1 becomes row 3. So 2, negative 5, 3, and 8. Now what's step 2? Step 2 is we want the second row, first column, to have a 0. So we want this 3 in the second row to be a 0. So how can we get there? Well, we can, I'll go ahead and start to rewrite the matrix. And what we can do is our first and third rows, those are going to be the same. So 1, 3, 2, negative 3. Our second row, I'm going to multiply row 3, or row 1 rather, by negative 3 and then add that to row 2. So negative 3, row, let me write that a little bit smaller here, negative 3, row 1 plus row 2. And then our third row, I'm going to go ahead and write that out, is going to be the same. 2, negative 5, 3, 8. So negative 3 times row 1 plus row 2. So negative 3 times 1 is negative 3 plus 3 is 0. So it did what it was intended to do. Negative 3 times 3 is negative 9 plus negative 1 is negative 10. Negative 3 times 4 is negative 3 times 2 is negative 6. So we're on this term right here now. So negative 3 times 2 is negative 6 plus 4 is negative 2. And then negative 3 times negative 3 is 9 plus 7 is 16. So we accomplished what we wanted to do. We wanted our second row, first column to be 0. So now what do we do in our next step? So we go on to the next row in step 3, and we want this 2 down here to be 0. So how can we get that to be 0? I'm going to go ahead and write this up here. We can do negative 2 row 1. Let's go ahead and write out, we know our first 2 rows are going to be the same, so 1, 3, 2, negative 3, 0, negative 10, negative 2, 16. And then we want negative 2 row 1 plus row 3. So negative 2 times 1 is negative 2, plus 2 is 0. So again, it did what we intended it to do. Negative 2 times 3 is negative 6, plus negative 5 is negative 11. Negative 2 times 2 is negative 4, plus 3 is negative 1. And then negative 2 times negative 3 is 6, plus 8 is 14. So again, our first step, we want row 1, column 1 to be 1. Our second step, we want row 2, column 2 to, or column 1, row 2, column 1 to be 0. And then our third step is we want row 3, column 1 to be 0 as well. So what's our fourth step? Well, now we want to make our second row, second column to be 1. So how do we do that? Well, we can multiply by our second row by negative 1/10. So I'm going to cheat a little bit here, and I'm going to go ahead and do step 4 and step 5 in the same step. So step 4 is we multiply our second row. So I'm going to write our matrix down. So 1, 3, 2, negative 3. And the second row, I'm going to multiply by negative 1/10, row 2. And actually, just so you can see it for clarity's sake, I am going to go ahead and just do that fourth step. I'll save the fifth step for the next matrix. I don't want to skip any steps and confuse you. So let's go ahead and just do this scalar operation first. 0 times negative 1/10 is 0. Negative 10 times negative 1/10 is 1. Negative 2 times negative 1/10 is 2/10 or 1/5. And 16 times negative 1/10 is negative 16/10 or negative 8/5. And we'll go ahead and leave our third row alone for now, and I'll save that for the next row operation. So 0, negative 11, negative 1, 14. So now our fifth step, I'll go ahead and get that in. We want row 3, column 2 to be 0. We want everything below this 1 in the second row, second column to be 0. So we want negative 11 to be 0. How would we do that? Well, our first two rows are going to remain the same. So 1, 3, 2, negative 3, 0, 1, 1/5, negative 8/5. And then we can multiply row 2, our new row 2, by 11, and then add that to row 3. So 11 times row 2 plus row 3. 0 times 11 is 0 plus 0 is 0. 11 times 1 is 11 plus negative 11 is 0. So we've done what we wanted to do. Now 11/5, 11 times 1/5 is 11/5 plus negative 1. So what is negative 1 in terms of fifths? It's negative 5/5. So 11/5 minus 5/5 is 6/5. And then negative 8/5 times 11 is negative 88/5. So this gets a little bit complicated here, but negative 88/5 plus 14/5, well, what, or plus 14. So what is 14 in terms of fifths? So I'm going to write this out to the side right here, just so we can see for clarity's sake. 11 times negative 8/5 is negative 88/5. And then 14, that'd be 10 times 5 is 50. 4 times 5 is 20. That's 70 fifths. So negative 88 fifths plus 70 fifths, that's negative 18 fifths. And now finally, our sixth step is we want that 6 fifths. So row 3, column 3, we want that to be 1. So how do we do that? Well, our first two rows are going to be the same. So 1, 3, 2, negative 3, 0, 1, 1 fifth, negative 8 fifths. And then how do we get that 6 fifths to be 1? Well, we just multiply row 3 by 5 sixths, the reciprocal of what we have in there. So 5 sixths, row 3. 0 times anything is 0. 0 times anything is 0. 5 sixths times 6 fifths is 1. And then 5 sixths times negative 18 fifths, that's going to be negative 18 sixths. But 18 sixths, that's negative 18 divided by 6, which is going to be negative 3. So now we have it in echelon, row echelon form, because we have a diagonal of 1s and everything in the bottom left-hand corner are zeros. So what do we do from here? Well, now we do what we did in the previous examples with our systems of equations that had 2 equations and 2 unknowns. Now we rewrite this as a system of equations. So we have x plus 3y plus 2 equals negative 3. We have 0x plus y. So y plus 1/5 z equals negative 8 fifths. And then last but not least, we have z equals negative 3. So what we'll do first is we will substitute into our second equation to find the value of y. So y plus 1/5 times what's z? Z is negative 3 equals negative 8 fifths. That gives us y minus 3 fifths equals negative 8 fifths. Well, if we add 3 fifths to both sides, that gives us negative 5 fifths. So y equals negative 1. And now we'll substitute z equals negative 3 and y equals negative 1 into our first equation to give us x plus 3 times negative 1. I should have a z here. I think I said it, but I didn't write it. So x plus 3y plus 2z equals negative 3. So x plus 3 times negative 1 plus 2 times, we solve for z to be negative 3. And that equals negative 3. So x, 3 times negative 1 is negative 3. So minus 3. 2 times negative 3 is negative 6. So minus 6 equals negative 3. That's going to be x minus 9 equals negative 3. And when we add 9 to both sides, we get x equals 6. So tentatively, our solution is 6, negative 1, negative 3. So how do we know this? We check to make sure that this solution works. So let's substitute in our first equation. 2 times 6 minus 5 times negative 1 plus 3 times negative 3. We want to know, does that equal 8? 2 times 6 is 12. Negative 5 times negative 1 is 5. And then 3 times negative 3 is 9. Does that equal 8? 12 plus 5 is 17 minus 9. That does indeed equal 8. So we check our second equation. 3 times 6 minus negative 1 plus 4 times negative 3. We want to know, does that equal 7? So we have 18 plus 1 minus 12. Does that equal 7? So that's 19 minus 12. That does equal 7. So that checks. And then last but not least, we have x plus 3y plus 2z. Does that equal negative 3? So that's 6 minus 3 minus 6, which does equal negative 3. So that checks as well. And that verifies that our solution to the original system of equations is 6, negative 1, negative 3. And as I said, the key to this is just remember to memorize the steps as they appear in the lesson. Step 1, you make row 1, column 1, 1. Then you make, in step 2, row 2, column 1, 0. And then step 3, row 3, column 1, 0. Then you make row 2, column 2, 1 in step 4. Step 5, you make row 3, column 2, 0. And then in step 6, you make row 3, column 3, 1. So in order, we make this one and then all these zeros. Then we make this one and everything underneath it 0. So we end up with this diagonal of 1s and zeros to the bottom left. Then we rewrite the equations that we have resulting from this row echelon form matrix. And then we substitute into the second equation because it's already solved for z. Z equals negative 3 in this case. We substitute into the second equation for z and solve for y. And then we substitute both z and y into the first equation and solve for x. And then as always, we check by putting each of the values into the original equations to make sure that they make true statements. So in this case, again, the solution to our augmented matrix, or the solution to our system of 3 equations and 3 unknowns using an augmented matrix and reducing to row echelon form using row operations is 6, negative 1, negative 3. X equals 6, y equals negative 1, z equals negative 3.